Hello, we're team number 5, and our project is EcoCycle. So for the SDGs that the project will align to are SDGs number 9, 11, and 13. The topic it mainly focuses on is waste management, the importance of recycling, the generation of clean energy, and the implementation of a circular economy in the state of Nuevo León. The issue the project deals with is the ineffective waste management that leads to several problems such as pollution, also health issues and climate change all across Nuevo León, especially in the metropolitan area. And the justification for this project, it's because we want to address Nuevo León's critical waste crisis. EcoCycle will try to replicate a waste to energy system that is already implemented in Singapore. This model cuts landfill use by over 90%, and it converts waste into clean energy. And well, this proposal directly reduces pollution, improves public health, and combats climate change.
The principal purpose of the plant is to reduce the pollutants as much as possible, liberate more clean gases, and to use the residues to make public constructions.
The description of this simulator is that the non-recyclable waste is sent to advanced incineration plants where it is carried with conveyor belts and burned at very high temperatures to significantly reduce its volume and thus the amount of contamination produced. Then the gases are released through a filtration system, minimizing environmental impact, and the ashes are reduced. In our version, we will include a digital award system that gives citizens incentives for correctly separating their waste. And new educational institutions will show how this process works and to be promoted through the community involvement.
The machine is made up from several key components: a shredder to break down materials, a trommel or rotary screen to separate them by size, a conveyor belt system for transport, a three-phase electric motor for power, and a PLC controller that automates the entire process. All of these are supported by a strong metal frame structure. And using SIMFAT, the entire system can be simulated to study material flow, energy consumption, and efficiency. This allows engineers to optimize the design, lower costs, and predict failures before building the physical machine, making recycling systems more efficient and sustainable.
So to create the layout in the simulator emulate 3D, the following steps must be followed. So first, it begins with the collection area, where trucks unload the waste at the transfer plant. Later, this area is connected to the recycling plant, and conveyor belts are added between the two to transfer materials from one zone to another, also including shredding machines. Then it moves to the incineration area, where the polluting smoke produced is filtered to release clean air, while the ash is collected and later sent to an area where it can be used as a construction mix. Here, turbines, conveyor belts, and filters are added to complete the flow. And finally, the simulation is run to observe the movement of the waste in real time. Here it can be analyzed the efficiency of the design and identify possible improvements, such as reducing transport times or increasing recycling capacity.
And finally, we made analysis of data and variables. And for the analysis of data, we analyze how much waste is produced, treated, and recycled in Nuevo León. And we compare these numbers with Singapore's model to understand how waste to energy systems could improve the situation. And for the analysis of variables, we, by studying variables such as recycling rates and energy recovery, we identified how changes in these factors could reduce pollution and make waste management more efficient.
Thank you.